yeah, let's participate and have some fun. So the first thing we're going to look at is drawing tree diagrams. So I know we did a little bit on Monday, but we're going to practice some more. Okay, so let's have a look at question 1. It says, Samantha walks into a soft serve ice cream shop. She has 3 ice cream flavors to choose from: vanilla, chocolate, and strawberry. She can choose 1 topping out of a choice of 3. The toppings are nuts, birthday sprinkles, and chocolate sprinkles. She also has a choice of flake or no flake. The question then asks, draw a tree diagram showing all possible combinations of ice cream. Okay, so before we even worry about drawing this tree diagram, we first need to check how many parts of the tree we're going to have. So the first part of our tree is going to include our flavors. We have vanilla, chocolate, and strawberry. Okay, and the question is nice enough to include abbreviations, so we just have to put V, C, and S. Then they also mentioned toppings, so this will now branch off. So we're going to choose our flavors or have our flavors listed, and then we use our tree diagram, the branches, to list the toppings. So toppings will make up the second part of our tree diagram: nuts, birthday sprinkles, and chocolate sprinkles. And then we have a third option, which is flake or no flake. Okay, so there's going to be 3 sections to our tree diagram. And on Monday, I said that whatever is mentioned first in the scenario question will be the first part of our tree diagram. So our flavors were mentioned first. So that's what we're going to list first. Now, just a heads up, this is going to be quite a big tree diagram and might even take a whole page depending on your handwriting. So take your new page and let's start from the middle, and we're going to start off with our flavors. Okay, so I'm going to do this one with you, and then you guys are going to try the next one by yourselves. So our flavor options, I think I'm going to need more space. We have vanilla, chocolate, strawberry. Okay, then we're going to branch off. So let's say, for example, Samantha has chosen vanilla. She now has 3 options for toppings. She can have nuts or birthday sprinkles or chocolate sprinkles. Same with chocolate. If you choose chocolate, it could be chocolate and nuts, chocolate and birthday sprinkles, chocolate and chocolate sprinkles, all the chocolate. Or she could choose strawberry flavor with nuts, strawberry with birthday sprinkles, strawberry with chocolate sprinkles. So that is our toppings. You don't need to include these headings in your tree diagram if you don't want to. Okay, and then lastly, the third part of our tree diagram will be the flake and no flake option. So Samantha could choose vanilla ice cream with nuts, and she has the option of flake or no flake. Same with birthday sprinkles, flake, no flake. Chocolate sprinkles, flake, no flake. Or chocolate ice cream with nuts, flake, no flake. And this is where my tree diagram is getting a bit squished. So my advice is always start off with pencil because, yeah, it's always hard to judge the spacing. Although as long as it is neat-ish and we can read it, don't stress too much in the exam. Yeah, hopefully yours looks a little bit neater. And then the most important part, the whole reason why we do a tree diagram is to have an outcomes column, to see all the different possibilities, all the different combinations that you could have with these flavors, toppings, and flakes. Okay, so now we literally read it as vanilla, we follow the line, nuts, flake. So first outcome is vanilla, nuts with flake. Vanilla, nuts with no flake. Let's see. No worry, Yanda, we just started. We're busy drawing our first tree diagram. Then we've got vanilla ice cream with birthday sprinkles and a flake. So vanilla, birthday sprinkles, flake. Then it's vanilla, birthday sprinkles, no flake. Vanilla, chocolate sprinkles, flake. Vanilla, chocolate sprinkles, no flake. Okay, so we've covered all the possible combinations with the vanilla flavor. Let's look at chocolate. So if Samantha chooses chocolate, she can choose nuts with a flake. So the first option is chocolate, nuts, flake. Chocolate, nuts, no flake. Or she can have the chocolate flavor with birthday sprinkles and a flake. Chocolate flavor with birthday sprinkles and no flake. Then chocolate with chocolate sprinkles and a flake. Chocolate sprinkles, no flake. So this might be one of the bigger tree diagrams you'll ever have to draw. Okay, so now we've covered everything with the chocolate flavor. Now let's look at strawberry. So it can be strawberry, nuts, flake. Strawberry, nuts, no flake. Strawberry, birthday sprinkles, flake. Strawberry, birthday sprinkles, no flake. Strawberry, chocolate sprinkles, flake. And the last one, strawberry, chocolate sprinkles, no flake. Okay, how many outcomes do we have after drawing this tree diagram? Kind of makes me want to have ice cream now, though. Don't know about you. Hey, Kia.
Yeah, no, hey. All kinds of ice cream, different flavors. Goodness.
All the flavors, all the sprinkles, and flake, definitely. Okay, 18. Good. So all you had to do there was go and count everything under the outcomes column. And we've got 18 possible combinations from those 3 flavors, 3 types of sprinkles, and flake versus no flake. Okay, do we have any questions? Did this make sense, the explanation? Nice, thanks, guys. Oh, no worries. So we have just drawn a tree diagram, quite a big one. And that's all we've done. So you might just want to take a screenshot so you have it to look at later. But Nelly, I see that your hand is up. Do you have a question for us?
Yes, ma'am,
Yes.
do we always have to like put, like, for instance, vanilla? Do we always have to say vanilla nuts and what's this, flake, to figure out the outcome, the total, the final outcome?
Yes. So it will help you answer questions to follow, like working out the probability. So I could say, what is the probability that Samantha chooses an ice cream with nuts? So then you'll use this outcome column to go and see where all the ends are. And then you'll be able to say, whatever, 18 or 9/18, for example. So you can't necessarily see that if we just do the tree diagram itself. It's a lot easier once you do the outcomes column. Does that make sense? Because alternatively, you can see how many outcomes based on your last part of the tree diagram. So if you go and count all those, it will also give you 18. But this helps you work out the probability. So this will help, the outcomes column help you answer the questions that are going to follow. Cool. Okay, I'm going to quickly go back up to the question so you can take a screenshot of that, and then I'll go back to the tree diagram, and those of you that are late can take a screenshot of the answer quickly. Let me just... Okay, and then here's the answer. I'm just going to zoom out a little bit because it's quite a... Okay. You guys ready to try one by yourselves now? Oh, wait, sorry. No, we still got a few more questions. Not bad. Okay, question 2 asks, what is the probability of Samantha choosing a vanilla flavored ice cream? Probability of choosing vanilla flavored ice cream. So we've got probability, in brackets we write vanilla. We know that there are 18 outcomes. So how many times do you see vanilla in our outcomes? Okay, beautiful. Ben and Lisa giving me the simplified answer. Okay, so if we go back to our tree diagram, we check how many times we see vanilla. We see it over here. 1, 2, 3, 4, 5, 6 times out of the 18. So it'll be 6/18. And we always simplify the fraction to 1/3. Okay, and that kind of question can be worth 3 marks, 1 for your answer, and then your simplified numerator, simplified denominator. Nice, nice, guys. Well done. Then, what is the probability that Samantha will choose an ice cream that does not have a flake? So that means we need to go back to our outcomes and count how many times we see NF for no flake. NF 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Good, thanks. You guys beat me to it. 9/18. So probability, no flake, 9/18, which gives us, good, nice. Glad you guys are remembering to simplify. Again, 3 marks for that. Hey, Let's try one by ourselves now. It's not going to be as intense, but there are 3 parts to the tree diagram again. So let's try this one. Question 2. A husband and a wife want to have 3 children. Draw a tree diagram showing all possible combinations of boys and girls that can occur with 3 children. Okay, so my clue to you is that you're going to start off with child 1 options. Your options for child 1 is boy, girl. Then you're going to branch off for the second child. And then you branch off again for the third child. So I'm going to give you guys a couple of minutes to try this by yourself. My advice is do it in pencil. And remember to start, well, with a little bit of space. So there's space for your branches to come. If you need any help, let me know. And you can just use B and G for, you don't have to write up boys and girls all the time. Okay, so I know it is a bit hard to show me your tree diagrams and the answer, but when you're done, you can let me know how many outcomes you got. Okay. That was quick, Annalisa. Okay, don't worry, Benedict. We're going to go through it now. Anyone else want to tell me how many outcomes they got? Okay, we'll check now. You might have just forgotten branches on one of child 2, maybe. Zimla, good. Okay, so we're getting quite a few different answers, yeah?
I don't understand.
Okay, who's speaking now? Nice, Evie. Exactly that. Well done. Okay, so let me go through this. Did we all list child 1 or do child 1 correctly? So we've got child 1 can either be a boy or a girl. Let's say, for example, child 1 is in fact a boy. Child 2 can then also be a boy or a girl. Or the first child could be a girl. So this family's had the girl, but the next child could be a boy or a girl. Got equal chance of being boy or girl. So that helps us identify our child 2 options. Then we've got child 3. So let's say, for example, the first child was a boy, second child was a boy. However, the third child could still be a boy or a girl. Or the first child was a boy, second child is a girl, but then the third child can be a boy or a girl. Or the first child is a girl, then the second one is a boy, but the third one could still be boy, girl. Or we could have a girl, then a girl, or boy, girl. Okay, so can we all see how I've completed child 1 can be boy or girl? Child 2, we've got the boy, girl options. Then we've got child 3, boy, girl, boy, girl, boy, girl, boy, girl. Okay, so then let's have a look. First child can be a boy. Second child can be a boy. Third child is a boy. That is one option. So that is our first outcome, is that all 3 children will be boys. Boy, boy, boy. Or it can be boy for the first child, second child boy, but then the third child could be a girl. So it's boy, boy, girl. Or child 1 could still be a boy, but then the second child's a girl, then the third child is a boy. So this just also shows you the order of the different combinations. Because you could have 2 boys and a girl, but it could be boy, boy, girl, or boy, girl, boy, or girl, boy, boy. But it's still 2 boys and 1 girl. It's just in the different order. Okay, or it could be a boy, then a girl, then a girl. So B, B, G. Okay, Ayabonga, can you tell me exactly where it's not making sense?
Hello.
Hi.
Ma'am, I thought, okay, the way I did it, I said child one could be a boy or a girl. Child
Yes.
two could be a boy or a girl, and a child three could be a boy or a girl. I really don't understand how you did it. I really don't.
Okay, so I see what you did. So you just did, but then did you branch out of each letter? So boy being the first one. So that's child number one. Let's just say it is a boy. But now child two is coming along, but we don't know what child two is going to be yet. But it has an equal chance of being a boy
Okay.
or a girl. So it has to have two branches coming out of that first B. But
Yeah.
then first child could actually be a girl then. So let's say it is a girl, but now child two can still have those options of boy and girl. So it needs to have two branches coming out of each letter every single time.
Okay.
That's a lot to take in, but so just always look at the first child, okay? And then
Okay.
pretend, okay, it's going to be a boy. We've got a boy now. But now child two, there's still two options. So we've got our boy, but now the next one can be boy or girl. We don't know. So two branches need to come out there.
Okay.
And then you go to the next one. Okay, let's pretend that the first child's a girl. Okay, but we don't know what the next one's going to be. So we still got our two options, boy, girl.
Okay. Yes. Okay. Now, okay. I think now I understand.
Okay. Yeah,
Yeah.
it's quite tricky because it's also like
Yeah, it
the
was-
same thing over and over again. It's not like the ice cream, it was flavor. We've dealt with the flavor. Now it's sprinkles, toppings, always boy, girl, the whole time. So I think that's why it's a bit tricky as well.
Okay. Thank you.
Okay, good question. I'm sure you're not the only one thinking that. Okay, so I have done the outcomes for the first half of the tree diagrams. I'm going to try explain the second half. So now let's pretend the first child is a girl. Okay, the next child can be a boy or girl, but we're going to pretend that it goes girl, boy, boy. So it's girl, boy, boy in that order. Or it can be girl first, boy, and then girl last. Or it can be girl as the first child, girl as the second child, boy as the third child. And the last possible combination is girl, girl, girl. Okay, so after every child they've had, we need to add two more branches because the next child still has two options. We don't know what the gender is going to be. Okay, so we need to still have those two options for everyone. If there was a fourth child, we'd go to each one of these and say boy, girl, boy, girl. Okay. So this question particularly is quite a common question. I have seen the 3 children scenario in some textbooks, in some past papers as well. So it's quite a common one. Okay. But for the most part in tests, you normally just fill in a tree diagram. It's very, very scarce that you have to draw one from scratch. So as long as you understand how it works, you will be fine. Okay, and then that gives us 1, 2, 3, 4, 5, 6, 7, 8 different outcomes. It's quite cool to see because you wouldn't think that there's so many different options when you just have 3 children, but there's 8 different combinations that you can have.
Wait, how?
Do we have any questions? Okay, so if I had to ask you based on this tree diagram, what is the probability of having 2 boys? Probability 2 boys. Okay, so we go and check our outcomes and see how many times we see 2 boys. So it'll be over here. Here I see 2 boys. Here I see 2 boys. 2 boys over there. So just 4 out of the 8. Which is the same as 1/2 when we simplify. Okay, so I didn't say in any particular order, I just said 2 boys. Okay, so wherever you see 2 B's in the outcomes, that will be 2 boys. If I said at least 2 boys, you would then include that one as well. But I just said 2 boys only. Okay, good. I can see the 4/8 coming through. Nice. Just remember, we need to simplify our fraction. Okay, so I know that this was a little bit hard, but like I said, in the exam, for the most, I think when it comes to tree diagram, you mainly need to fill in the missing outcomes or missing parts that they will erase out. Okay, so it's not often that you ever have to draw one from scratch. So don't panic, but we just practice this in case. But when we do revision classes, I will go through tree diagrams again. Okay. So this is one way they could ask you a tree diagram in the test. But yeah, it's not very often you go from scratch. You would get questions similar to this next one, and this should hopefully make you feel a little bit better. So let's have a look. So the second way they can ask you questions about probability or tree diagram specifically is give you a tree diagram, leave out a few things, you fill it in, or you answer questions based on the tree diagram. So looking at this one, it says, Samuel is a soccer fan and he wants to use his knowledge of mathematical literacy to understand the possible outcomes of a game. The possible outcomes of a soccer game are win, draw, or lose. The team that Samuel supports still has to play 2 games. Okay, so because there's 2 games, there'll be game number 1, game number 2. There are 2 parts to the tree diagram, which we can see over here. So the first game they play, they can either win, draw, or lose. Okay, but now let's pretend that they have won the first game. So it's a win, but the second game, they still have all 3 options, win, draw, or lose. Or they could draw the first game, but then the second game, they still have the possibility of winning, drawing, and losing. So each time we're going to have 3 branches sticking out for the win, draw, or loss. Okay. And we only do that twice because there are only 2 games. The first question says complete the tree diagram. So as you can see, I've highlighted the first missing parts. I'm going to label it A. The next one is over here, B and C. Quickly try that for me. So based on the information given, let's complete the missing parts. When you're ready, you can let me know in the chat. What is A? What is B? What is C? Nice. Good. So A is loss or L or lose. B is D for draw. And C is our outcome, which is L, D. And I think I saw all those answers there. Good, guys. Nice. Okay, let's try another question. Determine the probability of the team losing both games. What is the probability of losing both games? Any takers? How many times do you see L and L in our outcomes? Good. So before we actually can answer that, we need to see how many outcomes we have in total. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 outcomes. And out of the 9, there is 1 outcome that says loss and a loss for both games. And we can't simplify that anymore. So that is the final answer. And that could be for 2 marks. Correct numerator, correct denominator. So if in doubt, for whatever reason in an exam, and you have to give the probability, and you do not know what the numerator is, just try your best, but make sure that the bottom, the denominator is correct, because then you can still get 1 out of 2 marks. Okay, so just make sure that you've got that there. What is the probability of the team winning at least 1 game? Winning at least 1 game. Nice, good. Okay, so you picked up on the at least 1 game. So that means we include this because that's at least 1 game being 1. Here's 1 game being 1, here, here, and here. 1, 2, 3, 4, 5 out of the 9. And again, that is simplified already. So the answer stays as is. Okay, so this should make you feel better. This question comes from a past paper. How would you feel if you got this in your exam? Anyone want to let me know how they would feel? Would you feel okay if you got this kind of question? Okay, good. Awesome, good. So these are the most common type of tree diagram questions. We have to fill in missing things. Okay, and then answer questions based on it. So if you can handle this, you can breathe, don't stress too much. There's still time as well to practice drawing tree diagrams, but like I said, it's not a common question. We just practice drawing it so we understand how it works so that we can ace these types of questions. Okay, good. I'm glad you guys felt good about that one. Okay, so now we're just going to touch on two-way tables or contingency tables. So this is another way we can represent probability, but this is not very common in exams. I looked through quite a few past papers and I haven't seen one contingency table, but you never know. It could happen. So let's have a quick look. A two-way table or contingency table is a table that represents all the possible outcomes of 2 events taking place. So we can only use a two-way table if there are 2 things. So if we go back to the ice cream scenario, we wouldn't be able to do a two-way table there because there were 3 aspects. It was the flavor, the sprinkles or the toppings, and then the flake or no flake. If we're just looking at flavor and toppings, 2 things, we could use a two-way table. So tree diagrams are for 2 or more events taking place. Can still be 2 things, but it can be more, whereas the two-way table has to be 2 things specifically. Okay, so let's have a look at this example together quickly. It says, Karabo collects information about whether her classmates have cats or dogs as pets. There are 30 learners in the class. She collects the following information below. 5 learners have a cat and a dog. 6 learners have a cat but not a dog. 12 learners have a dog but not a cat. 7 learners do not have a cat or a dog. Okay, so show this information in a two-way table. So when we are looking at a two-way table, the column will be focused on one aspect. So if you want to look at cats first, and then the row going this way will look at the other animal, dogs. So for cats, you can say underneath, this is the heading, has a cat, does not have a cat. In line with the dogs. So remember, cats will now be the column and the dog information will be the row at the top. Has a dog, does not have a dog. Don't stress if you don't know what's going on. I'm just explaining and showing you in this one. This is how it works. But again, two-way tables aren't a common exam question. So I doubt you'll ever need to draw one from scratch. But we'll practice just in case. Okay, so this is how we're going to fill it in. We're going to look at has a cat and has a dog. That answer goes in here. How many learners have a cat and a dog based on the information given to us? A cat and a dog would be the first bullet point. So that makes it 5 learners. So you're going to put 5 over here. Then we follow has a cat, but does not have a dog. So that's the second bullet point. 6 learners have a cat, but don't have a dog. So we put 6 in over there. Vanille, I see your thing in the chat, coin or dice. What are you referring to? Like a two-way table. Can you put those in a two-way table? Yes, you can. You can throw 2 coins at the same time and put in a two-way table. You can throw 2 dice at the same time. Or you could throw 1 coin and 1 die because there's 2 things at the same time and put in a two-way table. Okay, then we go on to the next row. Does not have a cat, but has a dog. Will go into this block. Does not have a cat, but has a dog. That would be the third bullet point over here, and that is your 12 learners. And then the last one, does not have a cat, does not have a dog. So they don't have any pet 7 learners do not have both. And that's how you fill this in. This one's a little bit better, I think, than a tree diagram. And that's probably why it's never asked in an exam. So hopefully this will be the year. Okay. If you have any questions, let me know in the chat. But I'm now going to show you the next question, which I want you to try by yourself. I have drawn a skeleton table that can maybe help you out. But if you need help with the first one, you can still ask me. If you're ready to try one by yourself, look at question 4. So Benele, is like you read my mind about the coin and the dice. Good, Benele. It's like you were waiting for this question. Okay. Was it at the subterranean? Oh, okay, yeah, but it's not in a two-way table yet. Okay, so for those of you that are still trying to figure it out, I have done the answers for the table. I've drawn out the table. So again, we read it the same way. It's coming from H and 1 at the top here, so it's H1, then it's H and 2. H and 3, H and 4. Same with the T. Okay, so how many possible outcomes are there altogether? So our outcomes are these 2 rows, and that makes up 12. So there are 12 possible outcomes, 12 possible combinations of throwing a coin and a dice. and we would get the same answer if we had to draw a tree diagram. Okay, how many of the outcomes show an even number? So it's 1, 2, 3, 4, 5, 6. 6 outcomes. Nice. All of you got that. And then the last one, how many of the outcomes contain heads and an odd number? Heads and an odd number. Good. That is here. 1, 2, 3. Okay. Nice. Looks like you all understand. So how do we feel after today's lesson? Do we feel a little bit better about tree diagrams? I think we're fine with two-way tables, but let me know in the chats. How did you guys feel? See a thumbs up. Nice. Okay, while you're letting me know, please fill in our little poll. What's going on?
I am also going to drop the link to the quiz in the chat, and then I'm going to close the chat for a little bit so that it doesn't get populated and everybody can get access to the link. I'm going to post it again.
Okay, so I do see some of you saying it's still a bit confusing to draw a tree diagram. But yeah, like I said, if we have some time for revision classes or boot camp type things, I will definitely throw some tree diagrams in there. But please practice if you're practicing class. If you haven't done it in class, do all the exercises on tree diagrams possible. Practice, maybe look at some past papers. But like I said, it's very unlikely that you'll draw a tree diagram from scratch. You'll have something similar to that win, loss, and draw question, where you just have to fill in things or answer questions based on it. Okay. Good luck for the quiz, guys, and thanks so much for joining. I hope that you have a fabulous Easter weekend. Rest and enjoy your time, and I'll see you guys on Monday. There will still be a class. Even though it's a public holiday, so I hope to see you all there. We'll be starting the next course, which will be the second chapter on finance. So banking, interest, and exchange rates is the next course. So I hope to see you all there. Have a good weekend and good luck with the quiz. I know you guys will do really well.